Simulink. So why we use MATLAB Simulink? Okay, MATLAB Simulink is extensively used for various reasons. Okay, most of the time MATLAB Simulink is used for simulation purpose. Simulation of any system can be done using MATLAB Simulink. Okay, so it will be more of a if you look at the Simulink operation, it will be like more of a drag and drop option. Okay, so where you will drag the components of the MATLAB and put it together into the Simulink command page and then connect it to them, and you will try to mimic a system. So that is what we will do with Simulink. Most of the time we'll try to simulate a dynamic system, okay, by means of using a Simulink. We will try to simulate a behavior of the system. For instance, all of you are doing a design and fabrication project. So many of you can even model your DNF project using the Simulink and get some expected results. So these are all possibilities that you could do in Simulink. In the mechanical engineering, in the field of kinematics, they use this extensively. In the field of mechatronics, they use Simulink extensively. If you look at any sensor-based systems, okay, will definitely require a Simulink system to understand more about the system. So there are different systems can be modeled, dynamic systems, continuous systems. Okay, so it is kind of a big area. So we will see like 3-4 scenarios of how to create Simulink in today's class. So when you launch, so today most of us are using a MATLAB online edition. So for MATLAB online edition, you can use your college user ID and password, the LMS user ID and password. If you use that, you will be in a position to access MATLAB online very easily. Okay, so at your home, very easily you could access MATLAB via the campus-wide license. And once you launch the MATLAB, this is how the page will be launched to you. So there you could see a place called Simulink. If you click on this, the Simulink window will open. So you could open Simulink either by clicking this or by typing here in the command window Simulink. You click and enter, you will have the Simulink window being open. Okay, so this is how you will have to open the MATLAB Simulink. So creating a new model. Once you open the MATLAB Simulink, you will have the provision to create any models you want. Okay. So in order to create the new model, okay, what you have to do is you have lot of libraries. Okay. You have a lot of things called library, which will have like various element box which can be used for modeling a system. Sources. Okay. If you look at sources, sources will generally be the inputs. Okay. Speed. If you want to determine for the vehicle, you can use source. Sensor input, you could use source. Signals, generally, like sine wave signals, can be used for, source. Vibration input can be used source. So all these things, okay, various inputs, like can be pulled in from this library box. Math operations, various Boolean operations like addition, subtraction, all these things can be done using math operator box, like, so these provisions are available in the library source. We will show you very detailedly as we move on. So this is the workspace. So once you click on the Simulink window, the workspace will get opened, and then you could drag and drop things from the library source. You could drag and drop things into the workspace of Simulink. So that is how we will be creating the models in Simulink system. So Simulink libraries. So what are the different types of libraries we have? We have sources, as I said, they are the signal inputs. Okay, sensor, if there is a sensor, the input from the sensor will be coming in through sources. Sinks are the outputs. Generally, sink are the outputs. So the final elements will be coming from sink. So what all elements or blocks that you could find in sink is namely, like display system, scope. So these are all systems that you can find in sinks. Then we have continuous. Then we have something called continuous integrator and transfer function, which is nothing but there are a lot of mathematical operations like differential operation, integral operation. For all those things, we have like default blocks available in Simulink library, which you could pull. Basic math operations like product of two elements, summation, trigonometric operations. For all those things, you could get from Max. Similarly, we have Boolean operations. Logic gates, all those things can be pulled from Boolean operations. All these things can be pulled from a Boolean library. Okay, so these are all some libraries available. Like, so these are all different libraries. You can see, right? Continuous, discontinuous, lookup table, sources. So once you click on this, all these things will get displayed. You can select this if you want this. Select this. you could pull it. You want a time delay to be set into the model system that you are developing. Select clock, pull into the workspace. It will just pull. If you look at sync, this is sources. Sources the initial first stage. The source, all the element box listed in source we'll use as the stage one, first element, and all the elements that is displayed in the sinks will be the final one. This will be the final one. Display, scope, out. This will be the final one. Okay. And similarly, in intermediate we will use mathematical operations. Okay. So we will have an input and output. Input is sources, output is sink, and between inside this you'll have some logical operation happening, for which you could use any of these libraries. Okay, any of these libraries where a lot of mathematical functions will be there, which can be used to connect an input and output and see like what is happening by means of using this mathematical operation to an input value. Okay, so to create a model, okay, first to create a simple model. Okay, so here I am taking the scope. Scope is nothing but a sink. Okay, and sine wave is nothing but an input. I am connecting an input with an output. So this is how we create a Simulink model. Once you create the Simulink model, so to create the Simulink model, I'll just drag them and pull into the workspace, and I can set the parameters. I double click on this sine wave. I get a block like this, where I could give informations like what type of wave that I would like to generate. Okay, that is something can be done here. So this is the source. Sine wave is one type of source element. Okay, so this is how we pull the sine wave into the workspace. Okay, integrator is the middle function. Okay, it is an operator function. Okay, so to create a simple model, I am pulling in an integrator. Okay, direct, I'm not connecting the value directly to the scope. Rather, I am bringing in an operator called integrator into the system. Then I bring in scope. Scope is nothing but the output element. So if you look at the simple system, it's a sine wave with an integrator function, and then we have the scope. Okay, scope is the output function. So the values going in string are all going subjected to integral function, and then it is presented in the scope box. So these element box, in order to be connected and linked to each other, okay, you need to use arrowheads. So the arrowheads will be very similar to like how you use CAD tool. Okay, so you just drag, click the points, and move it onto the next element box. Automatically it will get connected. The usage of Simulink would be very easy, but it's very important. All the element box should be connected into the Simulink. You could generate algorithms by means of using the various combination of element box. So that is how we mimic the algorithms in Simulink. Rather than using code, we will be using graphical interface to develop a system. So any system, okay, if you go back, there is an integrator. If I double click the integrator, this dialog box will open. If I double click the integrator, this dialog box will open. If you double click the sine wave, this dialog box will open, where I could give some specific inputs with respect to my condition. Okay, and after giving the inputs to the sine wave and the integrator, what I do is I go for configuration. Okay, so I will configure my model. Okay, so various modifications I could do. Okay, so if you go to the model settings, this option will be there. Okay, where various changes can be done. Okay, then you could run the simulation. Okay, so run the simulation. Here you have start, you can use, or there will be a one like play button. You will have a play button in the online MATLAB. You just play it, you will get the software. So this is how you get the simulation results. Okay, so the summary is something like, what is that you understand as the first part of our discussion is how to create a simple system using Simulink approach. Okay, in generally Simulink is used to create any system. Okay, and we will simulate the mechanical system or any electrical system can be simulated by means of using Simulink. Okay, so we will see how to create a simple model. Okay, where we use a source sine wave operator. So this is a simple system. Okay, so to start with, we'll do with this. So I am going on to the MATLAB. I will start from fresh. Okay, so I go to this. I'll go to Google. click on MATLAB online. I click on MATLAB online. Okay. So you get the MATLAB homepage. Okay. So I have already logged into the MATLAB, so it is showing my name. So it is very important you also log into the MATLAB. After that, you click start using MATLAB online. So the MATLAB is opening in the cloud server. Okay. So now this is how you will get the MATLAB dialog box being opened. Okay. So now if you look at this, okay, there are options. You have an option called Simulink. You could use this button and also launch Simulink, or you could also use the command window Simulink and enter and enter. I think I'm making some mistake. Okay. So it is opening up. So there are two ways to open. You could click type in Simulink in the command window and enter. It will open. That's what I did now here. Or you could use the menu bar and click the Simulink. Automatically this page will come. Since I'm using a 32-bit system, it is very slow. If you use a 64-bit system, you'll have quite better experience. And of course, connectivity issues depending upon your network as well. So I'm waiting for the Simulink to be launched. So the Simulink is launched. So the Simulink is launched. If you click on examples, you could see some example files on Simulink. Okay, various examples are available. If you want, you could try some of those. Okay. So first, what I will do is let's think we are planned to create a simple model. So I'm creating a blank model. For this, I click on blank model. Okay, and I click create model. It is creating a model for me. So the Simulink space is open. Okay, the Simulink space is open for me. Now this is the library browser. This is the library browser where all the elements will be listed. I click on the library browser. It is loading. So the element box are available. Okay. So I showed in the screenshot like there are various element boxes available. So these are all the element boxes available in the systems. You can see Simulink is loaded with a huge data set of element boxes. So there is a huge possibility that you could model anything with respect to Simulink. Even unmanned aerial vehicle can be modeled. Vehicle dynamics can be modeled. All those things can be modeled. Robotic systems can be modeled. Radar, if your people are working in stealth, that can be modeled. Everything can be modeled in Simulink. If you're working on model prediction, like in that case you could use machine learning. You could use this toolbox. If you're working on artificial intelligence, you can use fuzzy logic toolbox. So if you're working on signal processing, you can use DSP toolbox. For all those things, we have provision in Simulink. Okay. So these are all libraries. So what I'm going to do is I have to pull this source. So I have to from the library look for source. Okay. So here is the source. I click on source. In the source, what is that I'm looking for? Sine wave. I'm trying to look for sine wave generator. Okay. I I click on sine wave and pull it into the screen. I got sine wave into the system. Okay. Next, I'm looking for integrator, right? So I am looking for integrator. It should be there in my continuous function. I have integrator, right? I am pulling in integrator. Okay. Next, I have input. I have an operator. Then what do I need? I need an output. So I am looking for output. Output will be available in the name of sinks. So click on sinks. So I am going to look for the output scope. Click, pull it. Okay. So I got what I want. I close it. Okay. So now I am arranging them in order, bringing in the operator, bringing in the scope. Now I have to connect them. For that, what I'll do is like I click on this arrow head of this element and then move my mouse towards the operator. Automatically it will get connected. Similarly, I click on this. I have clicked on it. Now you could see the arrow it's operating, giving me the directions. I move it till it connected to the scope. So I'm creating a simple system. Now I'm going to give some conditions to the sine wave. So as I said, if you double click it, you will get the parameters of sine wave which you could modify. So these are all things available. So if you go to the condition that we were discussing. So here we will give 3, 2. Randomly we are giving some input. I am giving amplitude as 3, amplitude as 3, frequency value as 2. I have given those two values. Next, when it becomes small, it is nothing but very similar to how you use the zoom operation. It is 50% in zoom. Okay, if you click on enter, so if you click on space bar, automatically it will fit into the screen. Or you could use this to fit in, or you could zoom in. Okay, now I'm clicking on the integrator. Okay, I'll give the initial condition as -1. I'm giving the initial condition as -1. As soon as click on this integrator, this dialog box opens. I click on give the initial condition 1, and I'm clicking in OK. Okay. So I set the values. Now I'm going to set the model parameters. In order to set the model parameters, there is something called modeling. Click on modeling. Once you click on modeling, this page will pop up where you could see the menu has changed. I click on model settings. In the model settings, click on model settings, Control E. One more dialog box will open up. So I will give some parameters. Okay, as I have in my. So I have start and stop time. I have it as variable setup. It is also variable setup. I will change this. It is given as dormant prince. I am setting it to dormant prince. So everything else is perfect. I click OK. Okay. So I have set the simulation conditions. Okay. So for any system, you will have boundary conditions. So that is what we will generally do with model settings. Then I click on scope. I click on scope. Okay. So this is where I expect my output. I am going to run the simulation. It is compiling. And if there is no error, then we will get an output. So this is the output. This is an output for a simple system. So if this question is asked, this is what you're supposed to do, and this output is something like you will have to load in as screenshot. Okay, this is creating a simple Simulink system. Okay, now in order to save the file, go to simulation. Okay, there's some option called save. Click on save. Okay, click on save as, and I'm giving it as one name. It is getting saved. This is how we create a simple Simulink model into the simple Simulink model using the MATLAB. Okay. Now I'm closing this window. Closing the file, my class. Okay. If you see that, you can see my class 1. SLX is the Simulink file is available. My class 1.slx Simulink file is available. Okay. Next, again, I create the, I want to go for next a different problem. So I click Simulink. Okay. So we will see what is the problem that we have got to discuss today further. So this is what we have discussed. So here we are also going to create a simple model. Okay. But here what I'm going to do is I'm using a gain operator. Gain operator is nothing but this is the signal. Okay. So I send this signal onto the system. Now this gain operator will multiply the value with 3 and then generate signal. And then what I'm doing is I am taking the source wave directly onto the scope box. I'm going to compare both the waves. So this wave is multiplied with the factor of 3, how this amplitude will be, and without the gain, how the amplitude will be. Okay, so these kind of things, how we will use is like in many applications, you will have many inputs coming from a vehicle. If you're developing a vehicle system, you have sensors, you have n number of sensors. So if you have different number of sensors, if you have 3-4 sensors, how to compare the sensors and their output? Like this only we will be in a position to do. For instance, ideal condition is the condition where you will have no issues. When there is a variation in sensor, okay, then you will be able to understand that this, there is some issue with the system, and accordingly system will get alert. So this is how we create systems. Okay, so I go and create a blank model. So I'm going to create a blank model. So we all know like where to go. Click on the library browser. So once I click on the library browser, I am looking for source. I go to source. The moment I go to source, I look for sine wave generator, click and pull it into the system. I look for sine wave generator, I click and pull into the system. Then I'm looking for a gain operator. In my case, I can also pick it from commonly used blocks because I already used this so many times. So anything that you use so many times will be available here. So we have the gain operator into the system. And then we have a scope. We again require a scope, which is nothing but from the library browser. You should always pull it from sync. Since we have done it already, it should be here. I have scope, commonly used blocks. So any operator, all the blocks that you're using frequently will be available here. So I am moving the scope. Okay. And then I am going to connect them. I am arranging them in a line. So this is something accidentally happened. So I'm deleting it. Now I right click it and move it onto the gain. Then I click on the arrow, move it onto the scope. Okay. So I define the system. Now here I have to create a loop. In order to create a loop, you're supposed to do is uh, you have to Sorry, in this case, I do the left click and dragged it. Now only I'm going to do a right click. Click this arrow, do a right click and then pull it down. See, and then bring it towards the output. Once again. So select it, right click. I have connected it. Okay. So I have connected the system. Now I'm clicking on the gain. So I am going to multiply the signal by a factor of 3. Okay. And then I'm clicking on scope. I'm going to run the simulation. You could see the two waves. You could see two waves. You could see the one wave is the regular wave. The other wave is the gained wave, which is multiplied by a factor of 3. So which means I'm able to compare outputs from different sensor. Okay, so this is all possible with respect to MATLAB Simulink. So what we are discussing are all simple systems. Since you are beginning with the application of learning Simulink, so I'm just exposing you with simple concepts. Later, like there are a lot of examples available. Okay, you could try those examples and try some complex systems. If you want, we will have later sometime, some MATLAB, workshops where we deal some complex systems. Okay. But for the exam perspective, we will get only the simple systems only for you for the exam. Okay. So next again, I'm going to save this file. Clicking on save as my class 2. So one important thing that you need to keep in mind is if you give a space while saving it, then your file will not save. Okay, so you should not give space when you save it. Okay. So my class 2 is defined here. Okay. So I am closing this application back. Okay. Now we'll see what is the next condition we can generate using Simulink. Okay, so let's take an application. Okay, so we just saw like how to use Simulink very no simply. Okay, like how to get yourself comfortable with Simulink. That's what we saw in the previous case. Now we'll see like how to do it with respect to an application. How we could develop a model, a mathematical model. Okay, how a mathematical model can be developed using Simulink is something we will see. Okay, so here we are doing for a simple application. Okay, creating a Simulink model to convert it to Celsius to Fahrenheit. Okay, so for that we are going to develop a Simulink. Okay, so if you see like 0 degrees Celsius is nothing but 32 degrees Fahrenheit. Now what is the mathematical formula for it is, if you look at this, the value is going to be the Fahrenheit value for the input should be degree Celsius. If you give an input of degree Celsius, it is multiplied by a factor of 9 by 5 and then it is added with 32. Okay, so this is the formula based on which the system is operating. We will try to develop a system. Okay, so if you look at this, I am giving the gain of 9 by 5. I am giving the gain of 9 by 5. Okay, you see like the gain of 9 by 5. In the previous case, we used 3, right? So I'm giving a gain of 9 by 5. Then I'm using, is this going to be a constant value 32? Yes, this 32 is going to be a constant value. So I'm introducing a constant operator. I'm introducing a constant operator 32. Then I'm using a summing element. Then I'm using a summing element. You see, I'm using a summing element. I'm using a summing element. Okay, so this value into the given input, okay, plus 32 gives me the Celsius value. So now I have modeled my MATLAB Simulink system. Okay, so this is how we do it. Okay, so we will do that now. So again, you click on Simulink. I click on Simulink. It's open now. Now what I'm going to do is I'm going to the library browser. Okay, I am looking for constant box. So I'm looking for constant box. So I get constant box. I need two of them. I pull two of them into the system. I require a gain to do the multiplication. So I bring in gain. Okay, and then I require a math operator. Okay. So I'm searching for the math operations, and it is available here in the menu. I click on this, and what is the math operation looking at is sum. So I should look for sum. So all this you see various math operations are available here. Okay. So many number of applications you could use. Sum is something should be in a, not able to figure it out here. I have it here. I move the sum. Okay. So this time I'm not using from the sinks. I'm not using scope. Rather, I'm using a display wave function. Okay. Whether I'll see that it's available here. If it is not done, we'll go to the sinks. Okay. Sync went up. Moving to sync. I clicked on sync, and then I'm pulling display file. Okay. I'm pulling the display file. Okay. Now I'm going to set the system. Okay. So this is the constant input. Okay. This is going to be my input. This is going to be my gain, which will actually the input value will be multiplied with this, and then this is summing operator. I'm using summing operator. The summing operator will, what it will do? It will actually multiply the constant with the gain value, and then add this constant, and then provide me the display. Okay. So I left click on element 1, connect it to the gain. I again left click onto the gain and connect it to sum, and again I left click on the constant box. Once again, I left click and bring it here. I left click and bring it here, and then I click to the display system. Okay. Now the factor here is 9 by 5. It's going to be 9 divided by 5. I put the value 9 divided by 5, and this is always a constant. 32. Okay. See, if you look at the slide, you'll be in a position to understand now. See, this is the input value, which is a constant value. So this is an input value, which is a constant value, which is actually multiplied by a factor of 9 by 5, which is multiplied by a factor of 9 by 5. And the constant value is 32. And the constant value is 32, always used in the formula, which has to be summed up this fact variable. So I'm summing up here and I am displaying. Okay. Now I am giving the input as 0. Okay. So let's run the simulation and see. I click on the run to simulate the model, waiting for the simulation to complete. See, I got the value as 32. I got the value as 32. 0 degrees Celsius, 32. So like this, okay, you could simulate any system which is having a mathematical framework. I'm changing it to 20. Clicking on OK, and then I'm again running the system. 68 degree Celsius, 68 degree Fahrenheit. So this is the output you get. So this is a simple application. For a simple application, I have used this. So you could use this for mileage calculation. Okay, in your house you could use this for mileage calculation. There are a lot of various applications, small applications. Like where we have some simple addition, subtractions. Okay, formulas can be solved using these things. Okay, I will save this. Save as my class. Initially might be slightly difficult, but as and when you know practice more and more, you'll be able to push develop lot of systems. Okay, so even you can try, many of you are working in DNF. You can try, working on solving your DNF problems using this Simulink as well. It's quite slow. Okay, so I'm closing it. Okay, so we saw some cases. Okay, similarly vehicle speed can be done. Okay, there is one problem for that is available. Okay, you could try that as well. Okay, now we'll go for developing modeling a simple mechanical system. Okay, so all these systems, you could model a thermostat, you could model your hydraulic, and anything that you do in your mechatronics laboratory can be modeled using the Simulink system. Okay, and any thermal system can be modeled. Okay, so, and any mechanical system can be modeled. Okay, cams can be modeled, springs can be modeled. Okay, whatever you are doing in your kinematics, KOM can be modeled using a Simulink. All those things are possible because most of them are operating based on a mathematical function. So if at all there is a mathematics involved, very easily that can be solved using MATLAB. Okay, here we take a classic example of a spring damper system. Here we take a classic example of a spring damper system. So you have a mass. This is the mass. Okay, and this is the spring, and this is the damper. Okay, and this is a disturbance. Just think this is a tire. This is a tire of a car. Okay, as the car moves, when there is some disturbances is coming in. Okay, so disturbance will act in this direction. When the tire goes over it, the disturbance will act in this direction, because of which the mass will start oscillating. Okay, once the mass begins to oscillate, as mechanical engineers, what we'll try to know, what we'll try to do is when this will be settled, when the mass will return back to the equilibrium. And we will try to develop a suspension system such a way like it should come back to equilibrium system very quick, even though even the driver doesn't realize like he has actually crossed a bump. So accordingly, we use the suspension system. So any car suspension system can be modeled. This is a simple thing I have actually shown you. You have to look at the components that is there in the suspension system of a vehicle, and then you could design the suspension system of the vehicle. Okay, and try a lot of modifications and see like how you could improve the damping factor, or how you could reduce the displacement of the mass when it passes through a particular disturbance on the road. Okay, so if you to look to study and understand the problem that we are taken. Okay, so this is the condition. Okay, so the force is acting in this direction. Okay, when it bumps on the car, the force is acting in this direction. Okay, once the force is given, what will happen is like this mass will start oscillating. Okay, and with respect to time, it will lose energy and it will reach the equilibrium position. Okay, so this is what will happen when the force is applied. Automatically, the displacement will happen, and slowly it will, die out with the time. So here, when the force acts, what is happening is like these are the following forces will act in opposite direction. Okay, the disturbance acts in this direction. Okay, if you look at the free body diagram, if you draw a free body diagram, all these forces will act in opposite direction. Okay, so this is the mass into acceleration. Okay, yeah, mass into acceleration. Okay, so we have the mass, and this is displacement with respect to time. Okay, and this is the damper. Okay, where it is a constant value depending upon the damper, which is dx by dt. I am showing it as x naught. Okay, which is more of this is acceleration and this is velocity, and this is the spring constant with the x value of displacement. Okay, so this is how the forces will act onto the system. And if you equate, it will be like F is equal to Kx plus C into dx plus dt plus m into d square x by dt square. So I need to know the displacement time, okay, displacement with respect to time. Okay, if you solve this equation, this is what we are actually we are actually looking to solve. Okay, so we need to know this factor. Okay, we have to solve this in order to get this. Now this can be done very easily using MATLAB. Okay. The system can be very easily modeled using MATLAB. Okay, so in order to model the system, this is the element box that we'll be using. Okay, if you look at the system, okay, if you look at the system, what you could see is the entire mathematical operation is being represented here. Okay, so what I'm doing is I'm using two integrator function here, and I'm using a gain function here. This is the force. This is the force that is acting here. Okay, so what is happening? The counter force is kx. Okay, the counter force is kx, where x comes from here. When the x value gets, it's multiplied with k and it's going in as kx. It is minus kx. And similarly, you have x coming in. C is given as a gain, c of dx dt. So it comes in here. You get the negative value cx. Okay, and this is multiplied. Okay, f, the constant value, minus kx, f plus minus kx minus cx into 1 by m. Okay, the gain gives me is equal to d square x by dt square. This value I'll get. When I integrate it, I get dx by dt. When I again integrate it, I get x, which is the displacement I'll get for a period of time. Okay, so I will create this model. Okay, so in order to create this model, what all things we require? We require one constant box, one add multiply, one add box, one add operator, one gain, three gains we require, two integrators, and one scope. So I click on Simulink. I click on create model. I go to library source. First, I will pick up a scope is there, so I need scope. So I'm moving in scope. Then I go to the library for the commonly used blocks. So because most of the items will be there. Simulink provides every of the elements that you use, frequently used in commonly used box. I am moving it. I need three gain. I need one constant. Pulling the constant. I need integrators. I need two integrators. I have taken two integrator. I need an add operator. Looking for add operator. It's not there, so I'll try to math operations. I look for add operator. Add operator should be here. I'm just figuring it out. Add operator. I have the add operator. Pull it in. Okay. So I have pulled all the system, all the things that I require. Okay. So I have the add operator. Delete it off. I am arranging them. I need an add operator. Then I need gain. I'm moving it. I'm clicking and dragging it. and then I'm clicking and dragging it. I'm clicking and dragging it, and then I'm putting two integrators, and then scope. Okay. Now I click on this add operator. I need one more operation there, so I put plus. So I made it as three operators. Okay. Now this gain, I want to rotate the direction, so I click on the gain and hit Control R. If I click Control R, the direction will change. I'm changing the direction of the gain. Similarly, I'm changing the direction of the gain. Okay. This is the system that we need to design. I'm bringing into the first plus. Connecting it to the element box add operator. This is the constant. Connecting it. So it's always left click and drag it. 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 And then I right click, branch out this line and connect it with this. Connecting it with this gain. Connected it. Again, right clicking this, connecting it with gain. Okay. Done this. For this is representing K. I click on this, give the value as K for time being for us to understand the model. K. I'm giving it as C. I'm giving it as 1 by M. Soon I'll change everything to value 1 by M. Okay. So I'm creating it. So if you look at this, so what is that we are doing is this is Kx, this is Cx, and this is 1 by M into F of Kx and this thing, but the operation is wrong here because we are given plus operator. When the F comes in, the Kx and Cx has to be subtracted. So we will work on that. So if you look at this, I have done a small mistake here. I'll delete this line. See, it is coming from year to year. So again, I right click, connect it here. I right click, connect it to K. Okay. So it is going here. It's coming here. So model the system. Now, what you exclude one and scope. This is only the system. This is only the system. So the spring damper system is this. Okay, this is an input and this is an output. So now I'm going to create a subsystem. Okay, putting all together, it as one unit. So for that, what I'll do is like I will click and select this. These are all one system. I've got scope also selected. So again, I'm doing it. Stopped. Now right click it here. you will get create subsystem from selection. Click on create subsystem from selection. Okay, so you will get the, now this is nothing but what you have designed, what you designed earlier, like that is what is designed here. We will mention this as MKC system. MKC system. I'm naming it as MKC system, and I right click on this to change color, just to show that you could change color easily. Okay, so change it to blue. I double click it. It takes me to the MKC system, where I click on this, and I'm going to change the operator as minus minus, because it is going to be CX minus and KC dot minus. So I click, make it as minus minus plus. So I change the system. Okay. I also like to give some values here to test the system. So I am giving the K value as 20. This is something with a spring constant. The damper constant value I'm giving it as 4. I'll give it as 3. Just let us imagine this M is going to be 1 by 4. As like just imagine, we'll take it as 4 M as 4, and I'm setting the parameters. Okay, I have set the parameters. Okay, now what I go is, I go back, I change the value of constant to 10. I change the value of constant to 10. Okay, then I go to modeling. I go to model setting. Go to model setting. I'll change this step to fixed step. Okay. And then go to solver details. I'm giving the step size as 0.001. Okay. And then I'm giving click OK. Okay. And then I'm going to scope. I'm clicking on scope. I am running the simulation. It is compiling. It is showing me an error. I'll have to correct it. Somewhere I have K listed. It's 3. Okay. It's 20. By 4. The thing is, okay, what is the issue? I'll again run the simulation and see. I have not defined any variable. I'm just confused from where I'm getting this variable K. Okay, I'll delete this. Accidentally I've created two MKC system. That is the reason why the problem was happening. Okay, I'll give the value as 20. I don't want to keep any variable. This is 1 by 4, and this is, she is going to be 3, and the operator I'm changing it to minus minus. Click on OK. So then I go back. I click on the scope box. I run the simulation. So this is the output we get. So what is that we are saying is like when the force is given, okay, the mass moves to a maximum displacement of 8, and then slowly, it is fading out with respect to time. So it almost takes 10 seconds. Okay, the current system, it almost takes 10 systems. It almost takes 10 seconds for it to come to the equilibrium state. Okay, so if it goes over a bump, okay, so depending upon the force, I've given the force applied as 10, so the bump should be a small force. For that, it takes 10 systems. So for the similarly, you could simulate this damping system for different force conditions and see like how these curves are coming. Okay, and then like you could also do that, bring in different spring constants. There are different types of springs. People who work on composite materials, nowadays people are working on even GFRP based springs. All those springs can be connected there, and like can be compared. For how we usually do is we create an ideal system. Okay, and for ideal system we'll create a Simulink model, and we'll see both are in synchronize. Then what we'll do is like we'll try to replace these components with new components and see whether they are able to reduce this time. That is one thing. And this jump, whether we will be in a position to reduce. So this is how we use Simulink. Okay, so I hope you had a better understanding of this Simulink. Okay, there are various things that can be done. Vehicle speed can be modeled. Okay, if this speed it goes, like at what time it will reach a destination, all those things can be modeled using Simulink. So there are various systems can be developed using a Simulink. Thermal systems can be model using Simulink. All those things are possible. So like for our case, try this 4 alone and see, practice and see. Okay, so I will, once again I'll stop recording here.